So now let's find the rates of change from the graphs of nonlinear functions. Nonlinear functions are functions that do not have constant rates of change. Therefore, their graphs are not straight lines. The slope is not constant if the function isn't linear. We can find the average rate of change between any 2 points by finding the slope of the line. And specifically, this is the slope of the secant line. So if you remember from geometry, a secant line is a line that connects 2 points on a curve. Right? So if we have a curve and we connect 2 points, that's a secant line. We can find the slope of a line, and the slope of the secant line is the exact same thing as average rate of change. So average rate of change equals slope of the secant line for nonlinear functions. Right? So here we have a little example. Right? So our function is the blue one. Right? And we have 2 points. Right? We have f of a taken when x is a, and f of b when x is b. The average rate of change of f of x with respect to x over ab is equal to the slope of a line of a secant line. All right, so that means the average rate of change which is the slope of the secant line, can be calculated by taking the change in the y coordinates over the change in x. And the change in the y coordinates is f of b minus f of a. The change in the x coordinates is b minus a. And that gives us how we can calculate the average rate of change. And know that it's exactly the same as finding the slope of a line, right? But now we're connecting 2 points on a curve with a line, and that's what we're finding the slope of. All right, so average rate of change. The average rate of change between any 2 points on the graph of f is the slope of the line through these points. All right, so average rate of change, the m secant, that just stands for slope of the secant line. Right? So we take f of x2 minus f of x1. F of x2 is the value of a function for a given x. F of x1 is a value of a function for a different x value. x2 is one value of x, and x1 is the other value of x. Right? And it is the same as taking the difference in the y coordinates over the difference in the x coordinates. But here we're going to write it with correct terminology. All right, so we want to find the rate of change from the graph of a nonlinear function. This happens to be the function y equals x squared. Right? So we got a quadratic function. The vertex is at 0, 0. All right, so now let's find the average rate of change from of f of x from x equals 0 to x equals 1. Right? So when x is 0, y is 1, so we have the point 0, 0. When x is 1, y is 1. So we're finding the slope of the line that connects them. The average rate of change is the difference in the x coordinates minus the difference, the average rate of change is the difference in the y coordinates, right? So it's the value of the function. I'm writing x down, so but f of x2 minus f of x1 is change in y, divided by x2 minus x1. All right, so the difference in the y values, that would be 1 minus 0. Difference in the x values would also be 1 minus 0. So the average rate of change here is 1. Let's find the average rate of change from 1 to 2. All right, so we're still using the 1, 1, but now we're using the point 2, 4. So average rate of change, f of x2 minus f of x1, which is the change in the y coordinates, divided by x2 minus x1. All right, so I'll start with the larger value. All right, so this one can be the 4 can be the second value. So we have 4 minus 1 divided by 2 minus 1. And that would give us 3 divided by 1, or 3. So you see that this is a nonlinear function, and it does not have a constant rate of change. So average rate of change is not constant for a function that is not linear. Okay. Let's try another one. Now this one I made it a little easy too, because you can see the slope is 1 and 3 because we drew in the rate of change in the y and the change in the x. That I won't do that for any of the others here. All right, so now we have another quadratic equation. All right. This time we're finding the slope between these 2 points. All right, so UBX, we'll go left to right. So UBX2, Y2, and UBX1, Y1. Okay? But we're gonna use the right terminology. So here, see, if we're finding the average rate of change between those 2 points, we're finding the slope of the secant line between those 2 points. So average rate of change equals slope of the secant line between 2 points. All right, so average rate of change from -3 to 2. So the average rate of change is f of x2 minus f of x1 divided by x2 minus x1. All right, so we're making we're going to just go left to right. So we have 4 minus a -1 divided by -3 minus 2. All right, so that would be 4 plus 1, so that's 5, divided by -5, so that's going to be -1. All right, so the average rate of change is decreasing between those 2 points. Now, if we chose 2 different points, right, because this function decreases and increases, then it might be increasing. All right, so now this is a piecewise function, and you should definitely put that in your notes. I might have that in your notes already. There we go. This will be important for you to know for next year. All right, so piecewise functions is just a function that has different rules for different parts of its domain. And we remember that domain are x values. All right, so we're going to find the average rate of change. We're going to determine whether the function is decreasing or increasing or decreasing, and then I'm going to show you how to write the equation. And it's really easy for a function like this because it's pretty easy to figure out the parts. All right, so average rate of change. So we're going to first find the average rate of change from -1. So this is -1, -2. To 3, 6. All right, so that's our first piece. All right, so average rate of change is the difference in the value of the function, difference in the y values, over the difference in the x values. So that would be -2 minus 6 divided by -1 minus 3. So -2 minus 6, that's -8. -1 minus 3 is -4, and that simplifies to 2. All right, so the average rate of change from -1 to -1, -2 to 3, 6 is 2. All right, and so is that increasing or decreasing? Well, that would be increasing. So function is increasing. From x equals -1 to x equals 3. And how do we know? Because the average rate of change is increasing. All right, so now let's find the next piece. So we're going to go from 3, 6 to 6, 6. All right, so average rate of change. F of x2 minus f of x1 divided by x2 minus x1. All right, so we'll take the difference in the y-coordinates. That would be 6 minus 6 divided by, and then the x-coordinates, 6 minus 3. So 0 divided by 3 is the same as 0. All right, so we have average rate of change of 0. All right, so if the function's not increasing or decreasing, it must be constant. All right, so function is constant from x equals 3 to x equals 6 because the average rate of change equals 0. All right, now let's find the last part. So we're going to go from 6, 6 to 10, 4. And so average rate of change, difference in the value of the function, difference in the y-coordinates, over difference in the x-coordinates. Don't really need parentheses. I'm going to move this a little bit. We'll put that over there. All right, so that would be, all right, so 6 minus 4, the y values, over 6 minus 10. So that's going to be 2 over negative 4. So that would be negative 1/2. So the function is decreasing from x equals 6 to x equals 10 because the average rate of change is negative. Oh, I'm looking at the green there, and I really meant to write is positive. Let's fix that because average rate of change is negative. Because, well, that doesn't have really meaning. So let's change that. I meant to say because average rate of change is positive. Function is increasing because average rate of change is positive. All right, so from negative 1 to 3, the function is increasing because the average rate of change is positive. From 3 to 6, the function is constant because the average rate of change is 0. And then from 6 to 10, the function is decreasing because the average rate of change is negative. So now let's write the equation here. So the first part's really easy, right? So I'm looking at the first piece, which I'll label in green. So this is a linear function, this part here. And we've already identified the average rate of change is 2. Right? That's the same as the slope, right? So the slope is 2. And the y-intercept is right there. The y-intercept is 0, 0. So that part of the graph is pretty easy. So this is a function, it's a piecewise function, and we're going to have 3 pieces. So this says f of x equals, we're used to writing 1 rule. We're going to write 3 rules, and we're just going to specify when to use each rule. And I'm going to show you the correct format for writing this. All right, so the first part, we're going to use the rule 2x. And when are we going to use it? We're going to use it if x is between negative 1 or 3. Right? So and to write between, we're going to write the lower number first. So negative 1, x, and then the 3. So this is read, f of x equals 2x, if x is between -1 and 3. Right, so that's the rule for that part of the graph. All right, so now the next part of the graph is the blue part here. This has a slope of 0, and no matter what x is, y is 6. So that's the equation, y equals 6, and we're going to use that equation when x is between 3 and 6. Right, so we don't have to write the y equals part because that's taken care of with the f of x equals. We just need to write the 6. Right, so that says that f of x equals 6, and when does it equal 6? If x is between 3 and 6. Now, we didn't say anything about equals. Right? Somebody's got to take the equals. Right? So, because otherwise we'll have a big hole in our graph, because at no point did we say what did we do when x equals 3. And it doesn't matter which one you use because it's the same value either way. Right? 2 times 3 is 6, and y equals 6. Just give it to the first one. We'll give it to somebody's got to take the equals. Right? So if you have no equals in there, there's going to be a hole in the graph because at no point would x equal 3. And if the two pieces meet up, then it doesn't matter who you give the equals to. Just give it to one of them. All right, and so now we have the last piece. Right, and so we know the slope of this line is -1/2, but we don't know the y-intercept. So to find the y-intercept, we're going to use point slope. So we use point slope to find y-intercept and that's the third part for part 3. All right, so if you remember point slope, let's see. Let's use it up here so I don't have to lean over. All right, so it's y minus y1 equals m. Actually, I'll write that part down here, and then we'll just substitute y minus y1 equals m times x minus x1. All right, so now we'll substitute. And let's use 10(4). All right, that'll be the x1, y1, because we're looking to write the equation for that piece. We can either use that one or we can use the 6(6). They're both on that little segment, but let's just use the 10(4). So that would be y minus 4 equals -1/2 x minus 10. We'll distribute the -1/2, so y minus 4 equals -1/2 x. -1/2 times -10 is a +5, and then we'll add 4 to both sides. So y equals -1/2 x plus 9. All right, and so now we can write the last piece. And if we think about it, this line's going to keep increasing with the slope of 1/2, right? Even though the line's not going there because we only use that line for between 6 and 10, right? We see if we continued it, it would have a y-intercept of 9. All right, so the last piece is to use the rule f of x equals -1/2 x plus 9 if x is, okay, so now we want to use that piece for between 6 and 10. All right, so if x is between 6 and 10, again, we want to fill in the hole. Somebody's got to take equals, so you can just give it to that one. It doesn't make any difference because those two parts meet up. And there you go. You have now learned how to find average rate of change in this one problem, average rate of change for a piecewise function. Right? You've learned about determining whether it's increasing, decreasing, or constant, and you've learned how to write a piecewise function, and you reviewed how to write the equations of linear functions. So a whole lot in one problem. We're going to do a few more average rate of change. They won't be as in depth as this problem, but let's do a few more. Let's find the rate of change from the graph of y equals the square root of x. Right? So first one is from 0 to 1. Right, so this point here is 0, 0. It's our starting value for the square root of x. And this point here is 1, 1. Right, so the average rate of change, which is the slope of the secant line, is the difference in the value of the function divided by the difference in the x values. Right, so that would be 1 minus 0 over 1 minus 0. Right, because this is the x2, this is the x1, this is the f of x2, if you will, or y2, and this is the f of x1. Right, and that's just going to be 1 over 1, which is 1. Right, now let's find the average rate of change from 1 to 4. Right, so we already got 1, 1 written there. So 2, 3, 4. Here we have the point 4, 2. Right, so we'll keep 1, 1 being x2, f of x2. So u be x1, f of x1. Right, so average rate of change is the difference in the value of the function over the difference in the x value. So that's going to be 2 minus 1. Actually, be consistent. I will take the 1 first, because that one's labeled first. All right, so 1 minus 2. Oops. Well, that's just what I wanted, isn't it? I must have hit. It's not liking me. I really don't want to have to do it all over again. Man. I can't get rid of this. Oh no. I can't see it. All right. Well, that was bad. That was very bad. If I wasn't at the last couple minutes, I would redo it. I must have hit the board to orient, and then I couldn't get rid of it, and then one was hidden under the screen recording. Blech. All right, let's finish. 1 minus 4. I will be very careful not to hit that again. 1 minus 4 1 minus 2. It's got me all discombobulated. Right? We want the difference in the value of the function. We want the difference in the y. 1 minus 2 over 1 minus 4. So that would be negative 1 over negative 3, which is 1/3. Right? So this is a slow-growing function. Here we can see that the average rate of change decreases as x increases. And that's because this is a slow-growing function. Right? I think I've got a couple more problems here where we're going to work from a graph. Now we have another rate of change from the graph of a nonlinear function, and this is y equals log base 2 of x. All right, so we want to find the average rate of change from x equals 2 to x equals 8. All right, so when x is 2, we have y is 1. And then let's take a look, and then I'll also show you, hey, what if we didn't have a graph here? How would you find the value of the function? And then 8, when x is 8, y is 3. I mean, the other way, yeah. I'm saying the right thing. When x is 8, y is 3. All right, so now what if we didn't have a graph? All right, so, and we just knew the 2 and the 8. All right, well, y equals log base 2 of 2. In other words, that 2 there, 2 to what power is 2? Well, 2 to the first power is 2. So that means that y would equal 1. And that's right, just what we have there, right? 2, 1. Let's try the next one. Y equals log base 8 of, log base 2 of 8. The base isn't going to change. No matter what, it's log base 2 of, and we'll plug in the 8, right? X equals 8. Right? And this is saying 2, right, to what power equals 8? Well, that would be 2 to the third power, so y would equal 3. So if you didn't have the equation, that's okay. You could, didn't have the graph, you could still evaluate given the equation and the x values, because remember, y is the exponent. You have to raise the base 2 to get some result. Right? So the x equals the result, and y is the exponent. All right, so now let's find the first one, average rate of change from 2 to 8. So average rate of change is the difference in the value of the function over the difference in the x values. All right, so that's going to be 3 minus 1 over 8 minus 2. All right, so 3 minus 1 would be 2. 8 minus 2 would be 6, so that's 1/3. All right, now let's find the average rate of change, which is, the difference in the value of the function over the difference in the x value. And this time it's between x equals 1/2 and x equals 4. We can easily see 4 there. And let's go over how we would get this point, 4, 2. And then how to find 1/2, because you might be like, well, I'm not sure where to put the 1/2. All right, well, let's talk about that. All right, so if y equals log base 2, we want x equals 4. All right, so y equals log base 2 of 4. That's saying 2 to what power is 4? Right, and we know that's 2 to the second power, right? So y equals 2. All right, so that's the point 4, 2. Let's find the y value for x equals 1/2, because that's not as easy to find. So y equals log base 2 of 1/2. Right? In other words, 2 to what power is 1/2? Well, 2 to the -1 power, right? If you raise to the -1, it flips. Right? So that means y equals -1. So here's our point right here, and that is 1/2 -1. Oops. That's really sloppy. All right, so now we have 2, right, difference in the y's, 2 minus a -1 over 4 minus 1/2. All right, so that's same as 2 plus 1, so that's 3. And 4 minus 1/2, right, well, let's write that as a fraction, improper fraction, right? So 4 is 8 halves, right? So 8 halves minus 1/2 is 7 halves. Well, 3 divided by 7 halves is the same as 3 times the reciprocal, times 2 sevenths. So this would be 6 sevenths. All right, so the one interest, so what 6 sevenths is, of course, greater than 1/3. 6 sevenths is almost 1. And so kind of an interesting thing about log functions is that they have a faster average rate of change near the vertical asymptote. So look how steep the graph is as we get closer. The vertical asymptote is right here at 0, right? Because there's nothing you can raise 2 to get 0. Right? And then the average rate of change it slows down as x increases. Okay? So this one also has lots of stuff in it. I think I've got maybe one more log. Is that? Yes, I do. And I think that's going to be the last. Oh, no, I've got two. I've got one and then two. And this is the last one. Well, you know what? Maybe we'll do these last two on the next video, right? So the video doesn't get too long. All right, so thanks for watching. Bye for now, and I'll see you in the next video where we're just going to do two problems. Probably should have moved this one to there. All right, goodbye.